Look at almost any river from above, and you'll notice something strange. It doesn't go straight. It bends and loops and doubles back on itself, taking the long way to the sea. And it isn't just some rivers. It's nearly all of them. You can carve a river dead straight. Engineers have. And within a few years, the water starts to bend it back, as if a straight line were the one shape a river will not keep. So what is the water running from?
You'd think water would take the easy path, the shortest line downhill. But moving water hides a secret. A perfectly straight channel is unstable. Picture a stream running true. Now give it the tiniest flaw, a stone, a soft patch of bank, a gust that nudges the flow. The current leans just slightly toward one side. And here's the trap. Once it leans, it digs. The spot it leans into gets carved a little deeper, which pulls the water harder still. A wobble far too small to see becomes a curve. The curve becomes a bend. The river has started to wander, and now it cannot easily stop.
To understand why, you have to look inside the bend, at something you could never see from the bank. When water rounds a curve, it doesn't simply turn, it spirals. The fast water at the surface is flung outward toward the far bank, but the water down near the riverbed is slower, dragged back by friction, so it slides the other way, inward. Surface water out, bottom water in, around and around, a corkscrew hidden inside the current. Scientists call it secondary flow, and this quiet spiral is the engine of the whole thing. It drives the hardest push against the outer bank and carries sand gently toward the inner one. One current building two completely different shores.
The first person to explain this was, of all people, Albert Einstein. In 1926, he was thinking about a cup of tea. Stir it, and the leaves don't fly to the rim. They gather in a little pile at the center. Einstein saw the same spiral at work. Friction at the bottom sends a secondary current inward, sweeping the leaves to the middle. In a river, that very same current throws the fastest water against the outer bank, so that's the bank that wears away. Einstein didn't solve everything about meanders, but he found the seed.
Now watch what that does over years. On the outside of every bend, the water strikes hardest, undercutting the bank until it slumps into the river. That's the cut bank. On the inside, the flow goes slack and drops its load of sand, building a smooth curved beach called a point bar. Erode the outside, build the inside, and the entire bend slowly shifts, like a wave frozen into the land, crawling sideways across the valley. The most restless rivers can migrate tens, even hundreds of feet in a single year. The river isn't just bending, it's on the move.
Bend by bend, the loops keep growing, swinging wider, their necks pulling tighter, until two parts of the river almost touch. And then, usually in a single flood, the water gives up the long way around and punches straight across the neck. The loop is abandoned in an instant, sealed off at both ends, left behind as a lonely, curved lake. An oxbow. Fly over a great river's floodplain and you'll see them everywhere. Crescent lakes and the faint scars of older ones, the ghosts of loops the river has already outgrown. A map of every path it used to take. Here's the part that surprised even the scientists. If meanders came only from mud, from crumbling banks and shifting sand, then only muddy rivers should make them, but they don't. On the bare ice of a glacier, streams of blue meltwater cut looping channels with no soil to erode at all, and they meander in perfect curves, exactly like a river. Out in the open Atlantic, the Gulf Stream, A river of warm water with no banks whatsoever swings into vast meanders and pinches off spinning rings, exactly like oxbows. And on Mars, spacecraft have photographed the dry, sculpted channels of rivers that vanished billions of years ago, still frozen mid-meander. Different worlds, different stuff, the same restless curve. Because meandering was never really about the mud. It's about what moving water does when it's finally free to wander.
There's one last twist. Some have claimed that if you measure a river's winding length and divide by the straight distance across, the answer, on average, comes out to pi, 3.14. It's a beautiful idea. But when researchers measured hundreds of real rivers, the true average landed closer to 1.9, and a river only officially counts as meandering past 1.5. So the magic number is more story than law, but the pattern underneath it is real. Rivers are almost always longer and curvier than they need to be. So the next time you cross one, remember, it isn't lost and it isn't lazy. A straight river is the strange one. Given water and time, the world always bends. The world beneath the surface is stranger than it looks. Subscribe to Wonderground for more stories about how the living planet actually works.